Today we are going to do some practice about what you call gradient. Gradient simply has to do with the slope. Okay. Now, if you have any problem that has to do with gradient, the first thing to do is to look at your reference table. You get here reference table page number 1. On this page number 1, you're gonna find the formula for gradient right here. This is the formula you have to use for gradient. Gradient equals change in field value divided by distance. So let's write this down here. So gradient equals change in field value divided by distance. Okay, now let's do some practice and see how we find the gradient using this formula. So the first one is this one, this map right here, and make sure to read everything. So basically we have here, it says on the topographic map below, points A, B and Y and Z are reference points on the topographic maps. This symbol 533 represents the highest elevation on Aurora Hill. Now here they give you this information, which is that the contour interval is 10 feet, meaning that when you go from this line, for example, to the next line, you go by 10. Okay, so now to find the gradient between, let me say the question right here. That's the question right. It says calculate the gradient between point Y and Z on the map, and it says label it the answer with the correct units. We're gonna see what is this exactly. Okay, correct units. So the first thing to do is to use the formula we talked about, is that gradient equals the change in field value divided by distance. Okay, now what do you mean by change in field value? Remember that we are talking about gradient between Y and Z. The gradient between Y and Z. So the change in field value means simply the elevation of Y minus the elevation of Z. Usually we start by the highest number, so that's elevation. Let's write this down here. Elevation of point Z minus elevation of point Y divide by distance between, to be precise, between Z and Y. Okay, so the change in field value simply means the difference in elevation between these 2 points right here, divided by, and the distance is simply the distance between the 2 points between Y and Z. Now first of all, you have to find the elevation of Z. Okay, let's go up here. So the elevation of Z equals, and also we need to find the elevation of Y. So the elevation of Y equals, now we know that this line here, let me use the red color, this line here is 500. Okay, you can follow this line. Okay, you can follow this line all the way here. So that is 500, and because I am going to go by 10, that's the contour interval, and since this is a hill, So when you go from here to here, are you going to go up or down? Of course up, because this is a hill. So 500, 510, and this must be 520 feet. Now if this is up, this should be down. So we have 500 minus 10. Again, remember, we're going to buy 10. So this should be the y here should be 490 feet. So once you find the elevation of z and elevation of y, you plot them in this equation. Elevation of z is 520. Let me just use the 520 feet minus the elevation of y, which is 490. That's right here, 490 feet divided by the distance between z and y. Now how can I find, let me just erase this off so you can have a clear picture of the map. So how can I find the distance between y and z? I have to use this. This is called scale. Okay, that's a scale right here. Okay, now first of all, I need to take a piece of paper and put right here. This is a piece of paper, and you mark y, you mark z on the map. Then you take this piece of paper all the way here. Oops. Uh-oh. Anyway, I'm moving the map actually, but let's drag this piece of paper. Now this first mark on y should be on 0, and the second mark you need to read. So let's go this way, and then something like this. So once you put the paper here, you mark y, you mark z, you put the paper so that the first mark should be on 0, and you see how much is the second mark. So this is 0, 1, 2, 3, 4, 5. So the distance here from y to z is 5 miles. Okay, that's how we find the distance between 2 points. So let's go now and plot this number here, distance between z and y. So we say it's equal to 5 miles. So this is equal to, let's put more space here. This is equal to, oops, this is equal to 520 minus 490. Of course, it's 30. Remember, don't forget the units. 30 feet divided by 5 miles. Again, why miles? Because again, the scale is given in miles right here. Okay? And now, simple division, 30 divided by 5 is 6. How about this unit? Remember that the unit act like numbers. Feet divide by mile. Feet divide by mile. But actually we don't write this like this. So actually how you write it like this. So it's 6 feet. Instead upon this symbol of divide, you just put slash like this, and that we read this slash per. 6 feet per miles. So what this number means, I talked about this in class, so I'm going to do it now again. It means that, imagine for example, this is, okay, you're going from Y to Z. Let's put here Y, and here for example Z. As you go from Y to Z, every mile you go 1 mile here. This means 1 mile actually. Every mile you go horizontally, like from here to here, that's 1 mile. You are going to go up 6 feet. 6 feet up. 6 feet. And this gives you an idea of a slope. Okay, the higher this number, the higher the slope. The lowest this number, the gradient is less. Of course, the slope is gentle. Anyway, every mile you go up 6 feet, so that's 6 feet per mile, and that's the answer for this question. Now let's do this